Today we're going to be looking at graphs of sine and cosine. So typically they're called sinusoidal functions when you do this. So both of them have a similar shape on the graph. Both of them are periodic functions, which means that any trig function that we have is going to be a periodic function. It's just a function that repeats itself with a specific horizontal shift. And so here's our period. What that means is if I have a function that goes like this, after every so often it repeats, that's the period. And if you look at this, you'll be like, okay, that looks a little bit like a wave. Sometimes sine and cosine are actually referred to as waves because of this. So here's what the sine function looks like on a graph. And from our unit circle, we should remember that at 0 radians, the sine function is 0. At pi over 2 radians, the sine function is 1. At pi, it was 0. At 3 pi over 2, it's negative 1. And back at 2 pi, it's just like 0. So here's the period. It goes from 0 to 2 pi, so the period is 2 pi. Again, we can find that anywhere on the graph. If we have more of this function, you would see I have a period of 2 pi again, because this graph continues up here back to 1 and goes back down. That's the same 2 pi as this is 2 pi. Cosine works the same way, except for the cosine of 0 is 1, so it starts at 1 and then drops down to 0, goes to negative 1, back to 0, and keeps repeating. And then at 2 pi, I'm back at 1. So again, there's the period, which is 2 pi in this case. So again, as with all functions, we talk about domain and range. Good news is for sine and cosine, all real numbers work for the domain. So we have all real numbers from negative infinity to positive infinity. And for a standard sine or cosine function like you just saw in the previous graphs, the range goes from negative 1 up to positive 1. There are a few things that we can change though on graphs. Alright. But first, we're going to talk about a little bit about whether they're even or odd functions. In this case, it gives us a couple new identities that we can use sometimes when we're solving later when we solve the equations. And here, since sine is odd, it's symmetric about the origin, which we saw when we looked at the graph of sine. It went through the origin and did this. So the sine of a negative angle is equal to the negative sine of that same angle. Whereas cosine is even, it's symmetric about the y-axis. We saw that when we saw those graphs that it curved up here and came back down. So the cosine of a negative angle is just the same as the cosine of the positive angle, which you can kind of verify that on your unit circle a little bit. So here's the real trick. When we have a graph of a function, or we want to make a graph of a function, we need to know how to start. So we've got a couple things. So in this equation, in sine or cosine, the a is going to be our amplitude. So it'll usually be the first number you see when you look at these. B is the horizontal stretch and compression, which is related to the period. So the period is equal to 2 pi divided by b, or b equals 2 pi divided by the period. So depending on what information you have, you can use either of these two to figure out what b is for your function. And k is the vertical shift, and it actually determines the midline. So if you look at those previous graphs that I showed, the midline was at 0 because it's halfway between negative 1 and positive 1. So the midline is going to be halfway between your peak and your valley, or your trough. Some people call this a trough on a wave, some people call it the valley. So there's a peak, there's a valley. Again, maximum value and minimum value. You use those to figure out the amplitude and the midline. So again, here's another picture. Again, the amplitude goes from the maximum to the midline, or from the minimum to the midline, or it's half the distance from the min to the max. So some of the problems we'll see, we'll be asked to sketch a graph, we'll be asked to look at a graph and write a function. So it's really easy to type this into Desmos, but I'm going to show you how to do this by hand. So let's go ahead and start with our regular sine function and go from there. So sine normally goes, this, we'll make this -1, this is +1, and we'll make this pi over 2, pi, 3 pi over 2, and 2 pi. We'll do the same thing with the negatives, negative pi over 2. Sine normally goes through 0, 0, and then at pi over 2 is 1, at pi back to 0, at 3 pi over 2 it's -1. Same thing at negative pi over 2, it's -1. So it bounces back and forth between these values, and it curves through each of those, and then back at 2 pi, and it does the same thing over and over again. So what happened here? Alright, this means the negative is it's a reflection over the x-axis, and the 3 means the amplitude is 3, which means it's stretched. So instead of going between 1 and -1, it goes between -3 and +3. So our midline stays the same because I don't have anything at the end like a plus here. Your midline would be out here. I don't have that. So let me change colors and show you. So what would happen? Well, 0 stretched up to 3 still stays 0. This pi over 2 normally is +1, but since it's a -3, I gotta take that and make it -3. So -1, -2, -3. And I'm gonna stay at this pi over 2. Then my pi is at 0, it's gonna stay at 0. My 3 pi over 2 is at -1, it's gonna now be at +3, because then I come back down to 0, and then so on and so forth. So I'm doing the opposite of what my original sine was. Now you can use your unit circle to help out with this if you want to sketch it by hand. Again, I don't expect you to go too crazy on everything and go like 30 points to plot, but it should kind of look like this. It goes up and then comes back down, hits that, goes back up to 0, comes back down. And it just keeps repeating that same pattern. Alright, so should have drawn that a little bit better. That should actually be the minimum value. So it hits that and turns around and comes back up. Alright, then we're also going to have graphs of the function. So really what we need to notice is where is the maximum, where is the minimum. So for the amplitude, I'm going between -1 and 7, so that gives me 6, but I don't want the 6, I want half of that for my amplitude, and that's going to be an amplitude of 3. My midline is going to be halfway between -1 and 7, and halfway between -1 and 7 is this -4. So you could do -1 plus -7 and divide that by 2 to get the midline. So my midline is -4. Y equals -4. And then for my period, I can actually count it off. Now, there's a couple things we can do. We can go from peak to peak, We can go from valley to valley, or we can go from a point on the midline to another point on the midline where it's going the same way. So here I'm decreasing, here I'm also decreasing, and those 2 points are a lot easier to see that the period is 2. Now, in my function, I'm going to choose this to be a sine function because as I'm doing this, I'm sine because at the midline, I'm kind of going through where it would be up here normally. So a sine function goes through the origin. In this case, I'm increasing through the y-axis, so it's going to be a sine function. I don't need my period in that. That should be an x. But I need this b value. So if you recall, I said the b value is the 2 pi divided by your period, which is going to be pi in this case. So that just leaves me writing my function. My a is 3. I've got sine, and then I've got pi x, and then I'm taking away my midline of 4. So again, our first step when we look at these graphs, I would say just start with the amplitude. We're going to look at the maximum value and the minimum value. So it goes from 3 down to 1. So our amplitude is half of that. So from 3 down to 1 is 4. And we divide that by 2, and we get our amplitude of 2. Our period in this case, you can pretty much look, now, I've got a maximum at 0 when x is 0, and I got a maximum at 4 pi, so that's my period for this function. And since the period is 4 pi, that means my b value in my equation would be 2 pi divided by 4 pi, and that is 1/2. And my amplitude also helps me with my midline. So halfway between the 1 and the 3 would be y equals 1. So there's my midline. So my midline is y equals 1. And since we have a maximum on our y-axis here, this would be a cosine function, because remember, cosine of 0 is equal to 1. So whenever we have a maximum on our y-axis there, that is going to indicate that it's a cosine function. So here we got to write our function. So it's our amplitude times the cosine, and then I've got 1/2 x, and in this case my midline is 1, so I'm going to add 1 at the end. So sometimes we have some horizontal shifts as well. In those first few examples, I didn't have any horizontal shifts. So it's pretty much the same form, except in the middle we've got a t minus h. So whenever we do a minus, that's moving right. So a minus 3 in the middle with the t would be right 3, just like we did before with our other transformations. And t plus 3 would be left 3. So just like we had that before. Some physics and math textbooks will call the horizontal shift a phase shift. I believe using just the horizontal shift like we're doing will be easier for you to see what happens on each of the graphs and everything. So again, in this example, we've got a function, we're asked to find the amplitude, the midline, the period, and the horizontal shift. So most of these are right here. So this 3 is the amplitude. So amplitude is equal to 3. This plus 4 is our horizontal shift. And since it's plus 4, that means we are going left 4 for our horizontal shift. Our midline is this number out here, so our midline is y equals 5. And the last thing is b. So in this case, b is equal to 8. B helps us find our period. So our period for this function is going to be 2 pi divided by 8. So it's always going to be 2 pi divided by whatever your B value is. And in this case, that ends up simplifying 2 pi over 4. So we had to find amplitude, our period, our midline, and our horizontal shift. Sometimes the functions will look a little bit harder. So the first one, we had that 8 factored out. Here, we actually will have to factor once we want to find our horizontal shift. We don't have to for our period and everything else. So amplitude in this case is 1 because there's no number out in front of the sign. It's just a 1. Our midline is y equals -3. So that's our midline. In this case, our B value is the number in front of x, which is pi over 6. So our period is going to be 2 pi divided by pi over 6, which ends up being 2 pi times 6 over pi, and our pi's cancel out, and we get 2 times 6, which is 12. So here our period is 12. Now to find our horizontal shift, we need to look at what can I factor out of both of these. In this case, if I factor this out, I get y equals sine, and I've got a pi over 6 in front of the x, so I have to factor that out to get my horizontal shift. And since it's plus pi, if I take a pi out of 6 out of that pi, that means I need a 6 here, because 6 times pi over 6 is pi. And then minus 3 still stays the same. So I could have started with that step if I would have wanted to. So that makes our horizontal shift evident now. So our horizontal shift is going to the left 6. Now, since this is a periodic function, sometimes when you go left 6 and you look at the graph of the function, you could actually go the other way and still have the exact same graph. So on some of these, when we're looking at these graphs and they've had a horizontal shift done to them, you have to kind of look at two different things. Sometimes it could be a sine, sometimes it could be a cosine. So I'm going to show you how to figure out both of the equations on these examples, and then when it asks you for a formula, you just pick one. So you can pick sine or cosine. So in this case, we're going to start like we did before. We find amplitude first. So in this case, our amplitude, we're going to look for our maximum value, which is 4. We're going to look at our minimum value, which is -4. So that tells you, okay, my midline is halfway between there. In this case, my midline is y equals 0. So that means my amplitude goes from 0 to 4. So my amplitude is 4. You could also do from 4 to -4 is 8. 8 divided by 2 is 4. So in this case, you can kind of see the amplitude is 4. Now the other thing that we can find from our graph to get started is our period. Now you might think peak to peak, all right, that looks a little bit hard to do. So I would suggest we look right here where there's this nice number, -6, and the function is decreasing to that -6, and we go to the next spot that the function is decreasing just like that, which is at 4. So here, your period is from -6 to 4, which is 10. So when we find our B value in our equation, B is going to equal 2 pi over 10, which in this case is pi over 5. Now, we can tell this has been shifted because our peaks aren't on the y-axis and our points where we're going down or coming back up, like this one, aren't at 0, 0. So when you look at these functions and they're not there, that means it's been horizontally shifted. And we have to figure out that shift. Now it depends on which function you're using. All right. So if we're going to use sine, sine is shifted 1 left. So we could use that if we wanted to. If we look at cosine, this peak is at like 1.5. So cosine shifted right by 3/2. Now, if it was me and I was doing this to be more exact, sine has the easier number to find. That 1 will be more precise than trying to pick this middle part here, which is, in this case, fairly obvious with 3/2. So I would choose sine, but you could do either one. So we got our amplitude, sine, we got our b value, and then we're going to do x plus 1. And in this case, we don't have a change in our midline, so we just leave that as a 0. Or we could write our function as cosine, and it would be the exact same function on the graph. So it would look the exact same way. It would just be a different graph. So this would be x minus 3/2. Alright, so same steps here. Again, the examples I have a midline of 0. You tell that by, this is -1 down at the bottom and +1 at the top. So that also translates to our amplitude being 1. So max of 1, min of -1 gives me an amplitude of 1 and a midline of y equals 0. Alright, and again, we're looking at our period to figure out. Now, this one has nice spots for our minimum values, being -1 at -7 and at 3. So that means, again, our period here is 10 on this graph. Alright, so that means our b value is, again, 2 pi divided by 10, which is pi/5. So again, we can look at either sine or cosine. One's more complicated than the other. If you look for cosine, this is left 2. So cosine would be left 2. And in this case would be the simpler function. If we want to do sine, we got to take notice of a couple things. Well, number one, it could be shifted here, but that's kind of ambiguous. These points are a little ambiguous as to where they're at. So we could use that, or we could use this point being about 1/2 and then do a reflection. So there are many things you could do here with the sine. I would prefer to just say cosine and leave it at that, but I'll show you how to do the sine here in a second. So the cosine is fairly straightforward. Our amplitude is 1. I'm going to do pi/5, then x plus 2. So that is the simpler of the two solutions. If we're going to use sine, we can use a shift of 1/2 right and a reflection over the x-axis in order to get this graph. So it would be a negative in front of the sine would get us this graph with a sine. So again, I would say we're just going to go with the easiest one to find when you have to do these, and then you'll be pretty much set to do it. So it could be either of these two functions. If you type these into Desmos and graph them, you will get the exact same graph. Okay.